Okay, so now come back to here. Okay, so let us refresh a little bit what we have learned last week. Okay, last week we have entered what we call it as magnetic induction. Okay, so for electromagnetic induction, okay, we must have what? We must have a force, okay, then cuts the magnetic flux. Okay, magnetic flux is the magnetic field line. Magnetic flux is at where? The permanent magnet or the current carrying conductor? The magnetic flux is found in the permanent magnet or current carrying conductor. Magnet, okay, correct. It's in a permanent magnet. It's a permanent magnet. So a force cuts the magnetic flux, then it will produce, okay, or it will induce EMF. And this, correct, is a permanent magnet. So, and this induced EMF, it will induce current. Okay, so this is what we have learned last lesson. Okay, so we have two places that we will look into for electromagnetic induction. One is in a straight wire and one more is in a solenoid. So in a straight wire, in order to identify the direction of the induced current, what we will use? Fleming's left-hand rule or Fleming's right-hand rule? Left-hand or right-hand rule? Correct, it is Fleming's right-hand rule. Fleming's right-hand rule, where this is the magnetic field, and this is the force, then this will be the induced current. Induced current. Okay? Can I? Okay. Then after that, we will look into what we call as the electromagnetic induction in a solenoid. So in a solenoid, okay, this one can be found in a wire, straight wire, or in a solenoid. So in a solenoid, okay, since it is a solenoid, so we will use a law to identify the direction of the current. What is the law? What is the law? Start with L. Correct. It is Lenz's law. Lenz's law states that the current always opposed to the motion that acts on it. So that's why if let's say that this is a solenoid, okay, this is a solenoid, okay, then we have the wire, insulated copper wire coil around it. Then you remember this one is connected to a battery or a galvanometer for electromagnetic induction. It's a galvanometer or a, yes, it's a galvanometer. Okay, it's a galvanometer. Because remember, it is where electromagnetic induction is to induce current. That's why we will use galvanometer to check the presence of the current. Okay, so if let's say I were to put a magnet, okay, this one is a north pole, this one is a south pole. Okay, so if let's say I move inside, so what pole is this? Yes, it is a north pole. Okay, it is a north pole. If let's say I move out away from it, it will be south pole. Correct. So then you use, once you identify the polarity of the solenoid, you can use right-hand grip rule to identify the direction of current. Okay, where your thumb always point at the north. Always point at the north pole. Okay, can I? Okay, so this is Lenz's law. Then after that, we have one more law we call as Faraday's law. Okay, Faraday's law. Okay, Faraday's law is actually a law to tell you that the magnitude of the induced current is directly proportional to the rate of change of the magnetic flux. Means that if let's say the changes of the magnetic flux increases, the induced current also will increase. Okay, so there are a few factors affecting the rate of the magnetic flux. Okay, one of that is what? Anyone can tell me or not? If let's say is in anywhere, in a wire or in a solenoid, okay, the factor to increase the rate of the cutting of the magnetic flux can be correct the number of turns of the coil, okay, because you can increase. Correct is the speed of motion, or yes, correct. You can use a stronger wire, so a stronger magnet, because all of this, it will help you to increase the rate of the change of the magnetic flux. Okay, correct. Thicker wire. Okay, thicker wire, because it will produce a reduced, lower resistance. Okay, so this is what we have learned on last lesson. Okay, so now I have what? How much time left? 3 minutes left. Okay, it seems we have 3 minutes left. I don't know why. Okay, you go out from this meeting already, come back again, then I will continue with 3.3. Okay, cool? Okay, see you later.